Hello and welcome back to another session of java9s.com. In this session I will discuss about the thread states and some of the important methods like sleep, yield and join. So from the creation of thread objects to their termination, threads transit through different states in their lifetime. So when we create a new thread object, the thread is said to be in new state. In this state, the thread is just like any other object that you create in Java. The thread object is not a real execution engine now, which will execute code. To make thread object to execute code, we should invoke start method on it. So when start is invoked, the thread is said to be in runnable state, and remember that in this state the thread is not executing any code, but it is ready to execute the code, but currently it is not executing any code. So when thread starts to execute the code in the run method, it is said to be in running state. Other than these two states, there are other states that thread can move or sleep. Other than these two states, a thread can also move to sleep, wait or blocked state. And when we invoke sleep method on the currently executing thread, we are telling it to pause for a specific amount of time. Apart from sleep, wait or a thread can go into wait or blocked status as well. These statuses are actually assigned by the thread scheduler. When the thread is in any of these three states, that is runnable, running or sleep, wait or blocking state, the thread is said to be active and alive. Finally, when all the code that is part of the run method is complete, the thread is terminated and it is said to be in dead state. And remember, once a thread is into dead state, we cannot start the thread back again. That means I cannot invoke t.start again on the same thread object. So the understanding of this transition between the thread states is very important. And coming to the sleep method, there will be some scenarios where you want a thread to stop executing the code for a particular period of time and then start executing the code again. So sleep method in the thread tells that the currently executing thread should go to sleep for the specified amount of time. And remember that sleep accepts time in milliseconds. It can throw an interrupted exception, so you need to surround the sleep statement in the try catch block. And remember that there is no guarantee that thread will go to sleep state at the moment sleep state immediately when this sleep statement is executed, and there's no guarantee that it will sleep for that specific amount of time. That means if you give 2 hours of time, there's no guarantee that thread scheduler will keep that thread in the sleep status. It can wake up the thread and make it run. So once a thread completes and it is out of the sleep state, it can be in runnable state or it can be in running state. So coming to the sleep demonstration, in the earlier thread demo I have shown the tortoise and hare example, and as per the story the hare must sleep for some time. But last time, because I have not introduced you to the sleep method, now let us see what happens when I invoke sleep on the hare's thread. So let us look into that example. Now here in the race demo I have two threads. One is tortoise one and the other one is hare. I have just named them as tortoise and hare, and once they are started, they are in the run method, and it is like 100 meters race, and I'm just checking if it is a hare thread or not. So I'm just getting the thread name, and once if the hare is at 30 meters distance, and I'm checking if the currently executing thread is hare, then I'm saying to it to sleep for 10 seconds. 1000 milliseconds is equal to 1 second. So I'm telling it to sleep for 10 seconds. Now when it is in this play, when the hare thread is executing this statement, then it will sleep for 10 seconds, and then tortoise will still be able to go through this, will complete this race and will be a winner. So let us see what happens when sleep is invoked. So I'm running this example. You can see that tortoise has already won the race, and we have to wait for few more seconds for the hare thread to complete. Yes, hare thread has started after 30 meters, and after tortoise has won, then after sleeping it has continued its race to complete the 100 meters. So this is how the thread can be made to sleep for some time, and we can pause a particular thread using sleep. But remember, I have surrounded this sleep statement with the try catch block because it can throw an interrupted exception, and there's no guarantee that the sleep method will make the thread to sleep for 10 seconds. I don't know if we have waited for 10 seconds or not, but not really sure. I think it must be more early that this hare thread is being woken up. So now let us look into the thread priorities concept. Understanding the thread priorities is important to know how the yield method works in multi-threading environment. Now remember that all the threads carry normal priority when you don't specify any priority for them, and priorities can be specified from 1 to 10, 10 being the highest priority, 1 being the lowest, and 5 being the normal priority. Remember that the thread with the highest priority will be given preference in the execution, but there will be no guarantee that it will be in running state at the moment it starts. So you cannot guarantee about its states that it will be in running state. It can even be in runnable state, or it can be in wait or blocked status, whatever it be. Then always the currently executing thread might have the higher priority than the threads that are in the pool waiting for their turn. So the higher priority threads will be given preference, and it is thread scheduler which decides what thread should be given a chance. We can use set priority method to set the priorities on a thread object, and remember that priorities should be set before the start method is invoked on the thread. And you can use the constants min priority, max priority, and normal priority to pass them through the set priority method to set the priorities. Now let us look into yield method. Yield is actually a static method, and yield tells the currently executing thread to give a chance to the threads that have equal priority that are waiting in the thread pool. So once the currently executing thread sees yield method, remember that yield does not tell a thread to go into wait or blocked state. The at most yield can only enforce the thread to move to runnable state from the running state, but not into sleep or wait or blocked status. So this is a most important point, and there is no guarantee that yield will make currently executing thread to runnable state immediately, and you cannot really guarantee that yield will enforce that the other threads will get an equal opportunity. So it all depends on the operating system, depends on the JVM, a lot on the thread scheduler. So let us see the yield demo first. Now I have created an yield demo here, and you can see that I have created 9 threads, giving them T9 and all of them into one group, all threads group, and I have an runnable target as yield runnable, and I am setting max priority for first 3 thread objects, normal priority for next 3 thread objects, and then minimum priority for last 3 thread objects, and I'm starting every thread here. Now what I'm doing when I start the each and every thread, the run method will get executed. Now you can see I have a log statement here which will print the current thread name and its priority, and at the end of the method I'm just printing an end statement here. First let us run by commenting the yield method to see how the execution goes on. So you can see how the priorities are. So in this you can see that thread with priority 10 are getting executed fine, and even they are going at the end, so completing the end. and then next bigger chance was given to threads with priority 5, and finally it is for the threads with priority 1, that is minimum priority. So let us see what happens when we actually invoke yield method. So whatever the thread that comes into run method to execute it and sees yield, then immediately it gives a chance for the threads that have equal priority that are waiting for their chance in the pool. That means priority 10 thread will again look into the pool to see if there is any priority 10 thread available. Then let me give a chance for that again to execute this run method. So it is like, giving the other equal thread an opportunity to run. So look at this, you can see priority 10 is started, then again priority 5 has already entered, then again immediately thread 3 with priority 10 has already started. That means all the threads with priority 10 are inside the run method, and then priority 5 is ended here, priority 10 thread T3 has ended. So you can see some shuffling is going on. So but remember, yield, you cannot guarantee anything with the yield. And here I have written some code to track the status of each and every thread. I would like you to go through this code once, just to print to show you how a thread state can be accessed. What all I'm doing is I'm just getting the state from each and every object in a while loop. So every time I'm just accessing the thread state and I'm printing it. Here I'm also accessing the nano time so that I can catch the difference in the status changes. Because thread executions are so fast that even you cannot grab them in the milliseconds. So here, once all the threads are terminated, then I'm just breaking out of this infinite for loop. It is very important that you should break at one point of time. So now let us see what will happen. So here you can see that almost all the threads have come to terminated state. Only one thread we are able to capture is runnable, was in the runnable state. That means the moment the main thread has started executing these things, all the threads have completed their job and are into the terminated status. So that's the reason why we're not able to capture it in lively fashion. So whatever, this is how you can access the thread status. Then coming to the next method, join method belongs to thread object and it is not a static member. When join is invoked, you're telling a strong message to the currently executing thread that you got to wait for some time until the current thread on which the join is executed should finish. That means when I say when currently executing thread is T1 and when T1 is executing and it finds that T2 dot join statement is in its path, then immediately we are telling to T1 to wait until T2 is finished. That means T2 has got some task which it has to be completed. Until then T1 has to wait. So it is like joining at the back of another thread. So any kind of functionality in thread is not really guaranteed, but join will definitely execute as expected. So to give a better example here, you can think of a situation where we have a slow train and we have a fast train. Now both of them have to take a single track. Now what we'll do, even though the slow train comes first, we'll stop it to make the fast train to move ahead, and then the slow train should follow it. So it's like, joining the other's track, or the better higher priority or the task that needs to be complete should be done first, and then the later will join the back. So we'll see a simple join demo now. Now you can see that I have two threads, first thread and second thread, and I have started first thread, and in this part I'm just getting the status of the threads. So here in run method, what I'm doing, I'm just getting this whichever thread, getting the status of whatever thread has started, and I'm just checking if the currently executing thread is the first thread. Then I'm telling inside this method to start the second thread, and then I'm also invoking the second thread dot join. That means I'm invoking the join on the second thread object. Then I'm telling that the first thread should stop until the second thread is finished with its execution of the run method. So now let us see if the first thread has finished, second thread is finished, then the first thread should also get finished. So we'll see how it goes. So you can see that the first thread is at the beginning, and once it is entering inside the join condition, the second thread has started it, and the second thread has also finished executing the run method, and then finally the first thread is finishing the execution. That means it waited until the second thread is finished with the execution. And you can see that the different status of each and every thread here. So you can access the different states when the executions are happening. So this is how join helps to make one thread to join at the back of the other. And there are other deprecated methods you should know which should not be used in the thread. That is stop, suspend, resume, and destroy. You cannot stop a thread when it is started, and you cannot use suspend and resume. You cannot even destroy a thread. These four methods are deprecated, and instead you should try using sleep method or interrupt methods to halt the threads for some time, or if you want to really stop a thread from its execution, then you can straight away throw an interrupted exception in between. So I have an interesting assignment for you. I want you to implement a relay running race program where 10 runners will be participating in 5 groups. That means each group will have 2 runners, and it will be a 400 meters race. Each person should run for 200 meters, and the second person should join to receive the baton to run the next 200 meters. I want you to implement this with a join with the help of join method. So this will be an interesting example, and once you implement it, you will get a good hands-on with the threads examples. So that's all for this session. You can visit java9s.com to download this PPT. The link to PDF is given in the description. And please do not forget to subscribe to receive the updates on more videos. Give your feedback as comments and hit like if this session was useful. Follow me on Twitter and Facebook at Java9s. Thank you and have a nice day. Bye.